represents, this really should be titled gametogenesis. So this is representing gametogenesis in the female, which we call oogenesis, gametogenesis in the male, which we call spermatogenesis. Spermatogenesis takes us to 4 spermatids. From spermatid to spermatozoa, this is actually a separate process called spermiogenesis. So spermatogenesis, we start with our diploid 2-end cell, which is the spermatogonia, that divides and becomes the primary spermatocyte. The primary spermatocyte will divide and become the secondary spermatocyte. These are haploid, that is diploid. The secondary spermatocyte each will divide and form 2 spermatids. So from one initial spermatogonia, the result of spermatogenesis is 4 spermatids that are haploid. By removing the excess cytoplasm and forming the mature structures of the sperm, we complete the process of spermiogenesis. So spermatogenesis occurs in the seminiferous tubules. Spermiogenesis starts in the seminiferous tubules and finishes in the epididymis. Oogenesis. You have the oogonium, which will replace itself. Then the oogonium will start to divide and become the primary oocyte. The primary oocyte receives the majority of the cytoplasm. One cell just receives the genetic information. This is what I call a polar body that is non-viable. The primary spermatocyte will then divide to become the secondary. The original polar body might divide again, so you might end up having 3 polar bodies, but the secondary spermatocyte is what will get the majority of the cytoplasm. So the secondary spermatocyte is what is ovulated into the fallopian tube, and if you have fertilization, so this is trying to show the nuclei of the sperm, as soon as the sperm goes through that zona pellucida, the secondary spermatocyte finishes completion and actually becomes the egg or the ovum.